Calculating the standard electrode potential of a half cell from the EMF. So this is if we maybe need to do some algebra. So we've been given a conventional representation and we've been told that the EMF, the difference between the two half cells, is 0.46 volts. We've been told the negative electrode, which we know goes on the left-hand side, has a standard potential of plus 3.4, plus 0.34. So this is on our left-hand side. This is where oxidation is going to occur, which means that our positive electrode must be our silver electrode. It must have a number bigger than 0.34 because the bigger one is always on the right. It's our question mark, our unknown. But we know that this is going to be where reduction happens. So write an equation for what happens at the positive electrode. Well, this is where silver ions are being reduced, gaining electrons to become silver metal. We know that at the negative electrode, our copper metal is being oxidized to copper 2 plus ions and 2 electrons. And then it wants us to calculate it. So there's two ways we can do this. There's the algebra way, which is that we know that it's right-hand side minus left-hand side. So we know that 0.46 equals our unknown, our x, minus 0.34. And we can rearrange and say that x is 0.46 plus 0.34, which is 0.80 volts. Or we can think of it on a number line. We know that from our 0.34, we need to add so that our 0.46 so that we can get to our new number. So we're adding 0.46 to 0.34 to give us 0.80 volts. On a number line, we've got 0.34, and we know that the right-hand one needs to be further away, and the difference is 0.46, and so we can work out it's 0.8 volts. Okay, so now we've got two electrode half equations in the lead acid cell in car batteries. It says here that the PbO2, PbSO4, so we can see PbO2 and PbSO4 in the top equation, PbSO4 with Pb in the second equation. So it's talking about the top equation. We know that this is the positive electrode. It says that here, which means it's the right-hand side, which means the one to be calculated is the left-hand side. And we know that the answer is 2.15. So we know that we've got a number line, and we know that the right-hand number is 1.69 volts. And we know that the difference is 2.15 volts. Where does the left-hand side lie? So we need to subtract 2.15 volts from 1.69. If you think about it like that, you don't need to worry about whether you're good at rearranging an equation. But if you wanted to do it from the equation, that it's right-hand side minus left-hand side, or more positive minus more negative, reduction minus oxidation, 2.15 equals 1.69 minus x, and we've defined x, okay? So we're going to say, we're going to add x to both sides, get 2.15 plus x equals 1.69, then we're going to subtract 2.15 from each side, and we'll get what x equals. Or we could have figured that out from our diagram. We were subtracting 2.15 from 1.69, and we're getting minus 0.46 volts.